All right, so check this out. In today's video, I'm sharing with you this exercise. It's this column that is decorative, but it's also structural. And it has all of these details. It has the connection plate, it has the bolts, the washers, and it has the column with a pattern on the outside. We can take that pattern and we can actually twist it and rotate it. So if we didn't want any rotations, we'll leave it at 0. If we want it to be rotated, we can do 360. But the other cool thing about this is if you have your own curves, you can set those here. Set multiple curves. And then we'll use that as the input. And you'll see that it will create those there, even though they're not the exact same length and they're located in different places. So that's one of the powers of parametric design, is being able to create blocks like these. So I'll be going over all of the steps here. I'll also be sharing the script if you want to see how this was made. So thank you for being here. Hopefully you're excited. And yeah, let's jump right in. All right, so the first thing I'm going to do is bring in a scale person. This way I know how big this design is going to be. And I can visualize some of the detail size a little bit better. All right, so starting with a line segment, we'll go here to SDL. Starting at a point, so we'll go to construct point. The direction is going to be up in the Z direction, and the length is going to be the height. Now here, what I'll do is bring in the endpoints. The other thing I want to do is I want to create an array here in the X direction, so we can create more than one. And this will be a guide so we can set more than one curve to apply the design to. We'll go here to array, linear. We'll go in the X direction by 120. And the count is going to be 3. All right, so starting here, I'm going to get the endpoints. Then bring in a circle component. We'll plug in a radius for this. So we'll go to 12 and then divide it by 2 so we can do the diameter. Now we're going to offset this to the inside. So we'll go to offset here in the negative direction. Now use a slider to offset to the inside. And so this is where the column is going to be located. What we'll do is we'll take this offset and divide it by 2. So create an offset again. So copy, divided by 2. What this will do is ensure that every time I offset that, I'm going to be getting the center line between those two. And what we need to do now is take that center line and use a divide curve component. This will be the location of your bolts. So we can change the number of divisions. And now we can create a size for the holes here. I'll copy this over so we can do the diameter, change the slider here to be a smaller number. do a maximum of 2 and use those points as the input. Now we're going to be creating the plate. So let's bring in the outside and we'll go to region difference. We'll be using this circle as the outside, curves A, and these circles as curves B, which now we can visualize a little bit better if we bring in a boundary surface. And notice that we have overlapping geometry. Well, let's bring in a graphed tree so we can make sure things are organized the same way. Now what I want to make sure to do is that whatever circle I inputted, like so I input this point as the circle, well, I want to keep this separate because I need to do this again to the top one, but in the negative direction. So with that being said, let's extrude this up. In the Z direction. And then we'll go here to .75, but then we'll change the max here to 2. And I'll disable the preview on this previous portion. All right, so now what we need to do is move those circles up to exactly that location. The reason why is because those are going to be for the washers. So we'll offset this by 0.25. And by 0. Now we can do boundary surface between those two. And extrude that. So this is extruded up in the Z direction. So we'll do that. These could be extruded up. Now there would be some cases where I don't want it to be extruded up, but actually that should be fine. If we have an issue, we can fix that. So we'll go to extrude. Now we'll copy this over. Now we'll go, let's say 0.25 for the washer. And then this is how far out you offset from the circle to get the washer. All right, so the same thing that we did here with these circles that we moved them up and we offset it. Well, those circles are going to be moved up again by the size of the washers. Let's go here. So it's going to be an addition between 0.75 and 0.25. And that is where we're going to locate some polygons. Now we do have circles here, but what's interesting is when you use the geometry of a circle, it'll actually reference the center point of that circle. So we'll use a polygon using the circle as the input plane. And you'll see that it actually does create them there. Now let's change the size. And then if you divide it by 2, we'll get the diameter. We'll do a max of 2 here. And then create a boundary surface and extrude it again. So using these 3, I'll copy it over. And now we've kind of set the stage for what we want to do up here, but also to know how much we need to offset to make sure that it doesn't intersect with at least the bolts here. So this will be hidden. And now we're going to do the exact same thing to the ones up here. So remember that I talked about keeping this separate, because all of these details that we created down here, we're going to do up here. So what we need to do is copy this over, but keep in mind, we don't want to copy the sliders. So only the script, leaving the slider. This way we're tying the numbers from this portion and recreating it down here, so we can just change one slider. And we'll do the exact same thing with the endpoint. Notice that all of the details will show up here. Now, the issue that we're having is that it's in the opposite direction. So either I mirror it relative to that point, or the reason why I separated it is because some of these dimensions need to be in the negative direction. So now we have all of this down here. Notice that as soon as I do that, it gets messy. Why? Because all of these sliders are routed all the way down here. So I do take my time and hide the input. For the slider, because I know it's contained within the one above it, and I don't need to worry about it down here. The fact is that I can always click on the component and know where the wire came from, so it's not really an issue here. All right, now that everything is hidden, the offset stays the same. This extrude, well, we go negative, double click here on the output because 2 wires are going into different inputs. And so now we can use a negative. Notice it now overlaps. This will also be negative. So create a relay, bring in the negative wherever you see a Z vector. I'm sliding it over, tapping Alt to create a copy. And now we have the exact same thing that we did down here, up here. All right, so this next part, we need to look at this from the top and see, okay, that is where the column pattern could go, or it can go even in between. Like if we rotate this halfway, we can have a portion of the pattern even start there. But I think that in terms of what we're doing here, we want to offset this again. So I'll tap this over, offset it again to the inside, copy over a slider and a negative component. So I can use this as a guide, because now this is going to be the size of what I sweep through each curve. So this is the one at the top. Now I want to do that to the one at the bottom, because the one at the bottom here is the same one that we want to sweep. One. So sweep this section relative to this rail. Now notice that it's not organized correctly, so we'll graft here. So now we have 3 curves sweeping those 3 circles here. So now we have the center portion of the pipe. And on this one, now we can take this one and do the exact same thing that we did with this one. So hide the wire. And sweep this section. As long as we just sweep it relative to this one now, that one is, you know, it's already kind of determined. The reason why is because now we're going to take this and use this to subdivide a pattern. So using isotrim, we're going to subdivide this surface using isotrim and divide domain squared, which will let us use a UV subdivision or a rectangular subdivision to break down that surface into UMV count. And now we can change the number of subdivisions. We can increase it like this. And this is going to give us a cool wireframe pattern that we could use structurally and also a little bit more decorative. So using a combination of both. I'll disable the preview on that original surface. And now that we have this, we can extract some wireframes so we can play around with this pattern now. We can just use this pattern, which is one of them, but we can also use a diagonal pattern that will need to actually break this pattern down into a diagonal. So let me show you how to do that. So we can do a regular rectangle subdivision, which is okay, but if we use deconstruct brep, then in here we have vertices, and we'll go to list item, and each rectangle has 4 points. So we'll go 1, 2, 3, and 4. And now we're going to create triangle subdivisions in between. So using a polyline, we're going to connect. Well, first we need to go to closed, set boolean to true, and then use a boundary surface so we can see the surface that the triangle creates. Now let's disable the preview on this, and we can start seeing when I plug in the first, second, holding down shift, and then the third one, that it creates the first triangle, starting first point, second point, third point, and creates a surface. Now we'll do that one more time, but we will skip one, and we'll go this one, and this one. So notice that just by doing that, we have created this diagonal subdivision, and we can also change the direction it happens by changing the index. If we change between 1 and 0, it'll change the direction in which it'll happen, because these are organized relative to this list item, and if we change the index, it'll change how it's organized here. So what we'll do now is take these surfaces and join them together. So brep join, Holding down shift, I can add more than one. Flatten the input to ensure that there's 3 open B-reps, which means that it's going to be those 3 separate ones as individual ones. And take this and bring in the edges. So B-rep edges. And now we can bring in a pipe component to plug in both the naked and interior curves into it. Caps, I like to use round, and then here the radius. Let's go to 0.500 divided by 2. That's the diameter. And so now we've created this wireframe part of the structure that is on the outside of the pipe. And this is one way to do it, using regular pipes, which is a more precise way of developing this. The reason why I say that is because I also like to use multi-pipe. Let me show you that. Sub-D multi-pipe, and I like to use 3 different sliders. Let's plug in the curves first so you can see what it looks like. And even just by plugging that in like that, I think it looks really good. We can change some of the inputs here. Strut size, and offset, and node size. Those are the ones that I like to change around. So now you're going to see 2 different options. This is one. And I like to route it through a geometry component because I know that that's going to be an output. Same with, all this stuff down here. So the bolts and then the washers. And those were separate because they were going in different directions. All right, and then the plate. Here's one and the other. You can also double click on the output and bring in a relay. Bring this one in, holding down shift, and then just use this as the input for the plates. Plates at the top. And this one. Now, the cool thing about this is that we can change how many we have. So let's say if we said we wanted 5, or if we want to set our own input, right? So if I go here and I want one like this size, and I want one with this size. Let's see if this works. Because that's the point of this script, is to be able to set multiple curves. So set multiple curves and then use that as the input. So notice that it does it to both of them at the same time, even though they're different sizes. It's not just a regular array, it's using the base curve as the input. So we know that it's working now. We'll route this through this one. Now we know the array is there, and then these are here where we can override. I'm going to clear values. We can change this to input any curve. And now the next thing I'm going to show you is this. How do we take a script like this and add another modification to it? So as long as you kind of know the steps that you took, and even if you don't, you could back engineer some of the information. Let me show you one modification that would take this a little bit to, I wouldn't say another level, but just add one more thing that you can, one more thing that can change the appearance of this. So with that being said, let's go back to our swept subdivided surface. And we're going to interject right here, because if we take that brep or brep, we can now, relative to the center of it, we're going to twist. The twisting relative to the center of each axis, we're going to rotate this brep relative to those axes. So I'm going to graph the input, change the angle to degrees, and now change this to 720. Now notice it's going to be twisting it in here. Now I need to override the input so I can see it reflected in the pattern that I created here. So the important thing to do here now is disable the preview on the things that are overlapping. So I want to now show you what it looks like with some color here. So we'll go to custom preview, bring in a color swatch. I'll bring in this small one for now, and start plugging in the pattern. So that already looks great. Next is going to be maybe the bolts, the washers. You know what, let's do this separate. And then the plate. And this center portion, the center portion of the column, we'll also do this, bring it all the way out from back there. I can disable the preview on everything here now because you don't really need to see any of this. I grouped it by accident there. And I'll hide hide the wire display on the custom preview inputs. And since they're all copied, I can kind of just move them all same time here. Select it over to the right, select it over to the right. We can kind of be aligned at least. And this will have to be something that will help us contrast and see the pattern a little bit better. And so the twist portion was what happened towards here. So if we said 0, it won't twist it at all. If we said 45, it'll twist 45 overall. So that's why when you do 360, it's a one complete twist, and you can do 360 and do a multiplication if you wanted to, right? If you said 360 looks good and you do 360 times 6, too much. Maybe 180 times 2 and then times 4. Just maybe multiples of 180. But what really matters is that you can change the angle if you want to, and if you don't want to, you don't have to. Using Subd multipipe, there are things here that we can change, but we also have different options. We have two options. Even though this is not being previewed, we can also do that with these. So I made sure to leave two different options because sometimes, you want one that's more. This one is easier to develop in the sense that you can find pipes that are the exact same size. Where with Subd, it looks nice because the connections are nice, but it would be a little bit trickier to develop something like that. So with that being shown, what I'm going to do now is clean this up. I'll have this available on my website for you to download and play around with. Let me know if you have any questions or what you think. What I like to do is to share with you guys tutorials and exercises that can help you learn more about parametric design. So hopefully you found this interesting. Hopefully you enjoyed it. And I hope to see you on the next one.